Our methodology follows the IPCC-AR5 vulnerability framework, which separates hazard from exposure and provides a more nuanced understanding of climate risk. This four-component approach allows us to distinguish between the climate events themselves, who is exposed, how sensitive they are, and their capacity to adapt, making our analysis much more actionable for policy intervention. Hazard represents the potential occurrence of climate events that may cause adverse effects using CHIRPS, precipitation data with 5 km resolution, and ERA5 temperature data from ESA. We identify extreme precipitation events, temperature extremes, and drought flood cycles. This component focuses purely on the physical climate events independent of human systems. We also have exposure, which captures the presence of people and agricultural system in places that could be adversely affected by this hazard. Using a NAO model 200 demographic data, we measure rural population density and also geographic location relative to climate hazards. This tells us who and what is in harm's way, which is conceptually different from the hazard itself. Sensitivity measures how much these exposed systems are affected by climate stimuli. Using a NAO model 200 data, we assess agricultural reliance, monetary poverty levels, and demographic factors. Communities more dependent on rain-fed agriculture and with a higher poverty are more sensitive. They feel the impact more severely when hazard occurs. Adaptive capacity remains the most policy-relevant component. It measures the ability to adjust, moderate damages, or cope with consequences. We leverage with multiple NAO models, Model 100 for basic infrastructure like water and electricity, Model 300 for education level, Model 612 for technology adoption, and the agricultural model NAO 02 for economic diversification. This is where targeted policies can make the biggest difference. The IPCC AR framework integrates this, and based into this formula, basically this multiplication and this product shows that high hazard exposure and sensitivity together create component vulnerability, while a strong adaptive capacity can significantly reduce overall risk. This approach allows us to identify not just vulnerable places, but specifically why they are vulnerable and which interventions would be most effective. And we will implement this through these three structural phases. And now we can see the project impact and contributions.